All right, everyone. Welcome to Season 2 of our show, True Data Ops. I'm your host, Kent Graziano, the Data Warrior. Now, in each episode, we're going to bring you a podcast covering all things data ops with the people that are making data ops what it is today. If you've not done so already, be sure to look up and subscribe to the DataOps.live YouTube channel, because that's where you're going to find all the recordings for our past episodes. So if you missed any of Season 1 episodes and you want to catch up as we kick off Season 2, that's the place to go. Now, to kick off Season 2, we have a very special guest today, entrepreneur, thought leader, expert advisor, board member, one of my mentors, a former CEO of Snowflake and author of the new book, The Datapreneurs, my buddy Bob Muglia, or Muglia.
Muglia, whatever. It doesn't matter. Good to
say
talk
it in Italian, yeah.
It's good
Welcome
to talk.
To the show,
Muglia
Bob.
is correct. Muglia is correct if you want to say it in Italian. So good to see you, Kent.
Yeah, glad you're able to make it. So we got you and I go back quite a ways, right? And with me joining Snowflake back in 2015, and we got to work a lot together. So I know quite a bit about your background from all of that, and I think most people probably know you as the CEO at Snowflake, but there's a lot more to your background, as I know. So if you wouldn't mind sharing with us a little bit about your career path so far and what you're up to these days.
Sure. I got started working on data really in the late 1970s, honestly, when my first computer job was actually at a small computer company called Condor that was working on data applications on Z80 based microcomputers in the very, very early days. And after a few years at Rome in the Bay Area, I spent 23 years at Microsoft, starting off as the first technical person on SQL Server, and then really spending a lot of time helping to build the server business, and did a lot of different things at Microsoft. Really ran a lot of different groups there, including Office and some of the MSN teams. But most of my time there was spent running server things. And at the end, I spent the last 7 years as the head of Server and Tools, ultimately the president of Server and Tools, and grew that business to about $17 billion while I was at Microsoft. It's a lot bigger now. I'll tell you, it's grown a heck of a lot since then. It seems like a big number back then, but it's gotten a lot bigger since then. After that, I spent a couple of years at Juniper in the Bay Area, and then starting in 2014, I took Snowflake forward as a CEO. Really built it from zero revenue to just about 200 million. And Kent and I were there together in the early days when we were trying to figure things out as to how to sell this product and how to position it and all those other things to the industry.
Yeah, that was fun. It's I've only worked for 2 startups in my career. The first one was a little startup company based on building some software on top of Oracle back in the early 90s, and that one eventually got bought by Oracle. But this was great. The experience at Snowflake was fantastic. I think I remember, I think Nancy finally told me I was employee 103 at the time. And, you were there all the time. I was commuting out from Houston, and we were all in that, one floor in office in San Mateo.
Yep.
That was fun.
That was the Snow What days. Everybody was like, Snow What? People would laugh at the name. They would laugh about it sometimes. And of course, nobody really understood how we could, we could do what we said we were doing. And it just took it took explanation of the architecture so people understood it. And then, people realized that it was for real. And we weren't kidding about what we said we could do. And, and it turned out pretty well.
Yeah. I remember some of the initial talks and things that I gave. I was speaking at like user groups and meetups. Got the same comment every time I, talk about the architecture and what it can do, and compare and contrast with my background in Oracle. And here's all these things that are just fantastic: the auto scaling and hands off, all of this in there. And everybody's universal response was, "That'd be great if it's actually true."
Right. Exactly. You'd get stopped in the middle of these talks saying, I've been doing data warehouses for 20 years and I know what you're saying is not true. And then you'd have
It can't be true.
Then you'd have to flip, which is my favorite moment if that happened. And then you'd spend 45 minutes on the architecture slide and you go through exactly what we're doing. And you sort of explain to people and they're going, and they go, really, is that really working? You go, yeah. And then they say, well, why wasn't everything else built that way? And the answer was because they were built before it was possible.
Yeah, before the cloud. The answer was the cloud.
It's just like the tools weren't there. The technology wasn't there to solve the problems that Benoit and Terry were able to take advantage of, and they were at the right time in the right place.
Right. And they had the background and experience to know what wasn't working. And they say, well, using the way we've been doing it, yeah, we're not going to get there because we've been trying to get there for years and we can't get there using this old technology. I remember one time you said, if somebody had come to you at Microsoft and said, we just need to throw SQL Server out and completely start over from scratch, that you probably would have fired them, and that ultimately you learned you would have been wrong, that this was the only way to do it, was start over.
And look what happened. I mean, it's really interesting to look at the Microsoft experience in the cloud, right? I mean, they've had a relatively rough journey getting to where they are now. It took them a long time. They went down several wrong paths because they had investments in technology, some of which, by the way, I set them on, 15 years earlier. And so they made somewhat logical choices, but not necessarily the right choices. Now that team has done a lot of rebooting since then, and I actually think Fabric is a very, very competitive product now, sort of their V3. But it's, what's exciting, I think, is that the ideas that we pioneered at Snowflake are now ubiquitous. And people would, the idea of separating storage from compute, and the way we were able to leverage the cloud and the cloud technologies are now well-known techniques and are being applied across the industry. And what's great from my perspective is there are now 5 viable platforms to build solutions on: Snowflake and Databricks, plus the 3 cloud vendors. I'm still a Snowflake fan. I'll always be a Snowflake fan.
Yeah,
I'll always prefer Snowflake. But the good news is customers have choices, and I think that's exceedingly healthy in the industry. And it's really always the way the database industry has been. There's, while there's a leader in the industry, and Oracle for a long time was the leader, the industry has always had multiple players, and there's always been multiple choices for customers.
Well, yeah, I mean, that's, the essence of, capitalism is you've got to have competition. Otherwise you have a monopoly, and then you stop having choices. And then once you stop having choices, you kind of stop having innovation because there's no need, right?
And there's no lack of innovation. All these teams are working their tails off to build the next capability. And now with artificial intelligence being integrated into the modern data stack, and that really is the way artificial intelligence is going to have its day in the sun. It's the way applications are going to be built within organizations, because those intelligent applications that are being created are based on the data that the organization has. And so using the techniques that are now well established in the modern data stack is the way people are going to do many or most of these applications.
Yeah. So let's talk about your book a little bit now that you brought that up. I think, your background in history and seeing through the evolution, all that has put you in, obviously, and really kind of an ideal position to write this book and talk about what's going on in the industry and see the future of the industry. And
right. You're just saying I'm old, Kent. That's all you're saying here is I'm really old.
We're the same age, Bob.
For a really long time. I've been around for a really long time. I saw all these things in the prehistoric days. Yes, it's true. I programmed in COBOL on a network database. It's true. It wasn't my favorite experience, and I wasn't very good at it, but I did do it.
Yeah. So in the book, though, you throw out some terms that those of us who are, semi-retired and not keeping up and just not expert data scientists, we might not be familiar with some of these terms. And I love the fact that you put a glossary in there because that helped me a lot in understanding. But a couple of things that if you could define for us, was foundation models and AGI.
Yeah, sure. Foundation models are this idea that you can use an immense amount of data, typically data found on the internet, to build a model that has some fundamental capabilities that can be leveraged in different ways. And what we're seeing right now are the large language models, which are very good examples of foundation models being leveraged to work with human languages and to be able to actually have some intelligence built in there. Other types of foundation models are visual models, ones that either understand images or create images. We're now seeing foundation models that are being built to create videos. Speech is another example. both hearing speech, understanding speech, as well as being able to speak to in human languages. Those are all examples of foundation models. And what's interesting is that you can take within these models and then customize them for a specific domain. And there are a number of techniques that are fine tuning is a technique that's being used. Another technique that's now being used is to use vector databases to store information and augment the model with knowledge in the form of a vector database. But these models are existing in a way that they can be applied to a given domain. And then over time, we're starting to see what's called multimodal foundation models coming together, which have multiple capabilities. And I think that's going to be very interesting in the years to come, where you have speech and language and vision and all these things tied together into
bringing
one
it all
model.
together. Yeah. So what's AGI?
So AGI is this idea that with this intelligence that we're beginning to see in AI, that the machines are able to do more and more things that previously only humans could do. And this has been the pursuit of computer science, certainly since I started studying it in the 1970s, and it really goes back much further than that, to the the 1950s and the early days of computers, where there's always been a view that computers would eventually get smarter and smarter and be able to take on more and more tasks of people. And the idea of AGI is really that the intelligence within a model has reached a point where you would say it has the same level of capability as an average human. We're not there yet. Everyone agrees we're not there yet. There is disagreement on how long it will take to get there. I think it'll happen in the next 10 years, but that's just a viewpoint. It's very much been influenced by the progress that we're seeing over the last 18 months. I continue to believe that time frame is reasonable. Some people think it's much sooner. They think it's just a few years away. Other people think it's decades away. I don't think so. If I look at my entire career, I knew this was coming. I knew that human level intelligent machines and ultimately machines that go beyond us into super intelligence. I knew that was our future. I've always believed that since I was a kid. I thought it was 2100, 2200 that would happen. I didn't think I'd see it. The big thing that's changed from my perspective is the horizon's moved in now, and I think it's quite viable to see this within the next 10 years. And then from that, we're going to see all sorts of amazing things, including intelligent robots and humanoid robots that live with us and help us in our daily lives, helping to care for elderly people, cleaning the house, doing daily tasks and things like that. And I think
Sounds like that's the Jetsons.
It's absolutely the Jetsons. It's absolutely Isaac Asimov. I mean, that's where my original thinking was all built, was in his science fiction that he wrote, with the laws of robotics. Which, by the way, if you watch any of those movies, they aren't really anything close to what Isaac Asimov wrote. Don't think that if you saw iRobot,
that's not it.
That was what he wrote. He didn't do that. That was very different.
You need to read the books.
Read the books. They're much better, and they're much more entertaining anyway. But he had envisioned this sort of a world, and I think it's what's coming. Will it happen by 2040? I don't know for sure, but given what I'm seeing, I think it very well could.
Yeah. Well, in your book, you say you see a colossal technological pivot in the years ahead, and the modern data stack is, while it's powerful now, it's actually immature and fairly inefficient for handling all the data management and analytic tasks we're going to need to accomplish. So I want you to talk a little bit about how you see that evolving. In the book, you've got on page 7, for anybody who's got the book, this arc of data innovation curve. Which I thought was fascinating. So maybe you could talk a little bit about that, of where you see this all going and how the modern data stack fits into that picture.
One of the benefits of being around for a long time is you have the benefit of perspective, and to see how things have changed over history. And looking back at how data, when I first started working with data, first of all, there was, it was the pre-SQL days, really. SQL had not been established. It was invented, okay, but System R was barely, a product at that point in time. And I was working first with relational technology in a non-SQL way at Condor. And then I worked with quite a few non-relational databases before SQL databases began to dominate in the 1980s. And, what I've seen is this progression of different data types over time being important. First it was structured data. Then we've seen things like text become very interesting, and search become a very, very important characteristic. It's clearly changed our lives in terms of the internet and things like Google. semi-structured data, which didn't exist for all practical purposes until the internet happened, and we started seeing applications create logs of information that they put in semi-structured JSON format. And now we're working with what I call, people often talk about it as unstructured data. I think that's a ridiculous term because images, video, text, documents, all of these things are highly structured. In fact, they're complex in their structure. So I call them complex documents, complex data. And we're now viewing those as all data sources. So to me, the thing that's interesting is that we're now moving to a world where we have more sources of data, traditional sources of data being structured business information and semi-structured information that's typically information about the application, log type information, as well as now we have incredible sources like video cameras, documents, things like that become potential sources, because we have, with machine learning, the ability to extract the data out of this information, of this content, and turn it into useful data for people to work with. So that's one dimension of the things that I think is changing in the modern data stack, is the breadth of types of data sources that people are working with. And we're seeing that pretty broadly as Databricks takes what they've done and brings in traditional database techniques, and Snowflake, from the opposite direction, is taking their database strength and now adding all of the capabilities of machine learning to work with many, many types of data. The other element, besides the obvious incorporation of models and machine learning models, artificial intelligence models, into all of these solutions to add intelligence in. The other thing that I think has been really interesting is to look at relational technology and the evolution of relational. I now believe that relational is locked in a box called a table. And it's locked there by this language called SQL. And I'm a lover of SQL. I'm a big fan of SQL. SQL's been very good to me, but it has some serious limitations. It's really good at what it does. If you're working with structured tabular information, while I can criticize SQL, and I can criticize SQL, the way they handle nulls is broken.
Yeah, CJ Date has a few things to say about that too.
Broken is the only way I can say it. It's wrong.
It's wrong.
Wrong. Yeah. But put that aside. SQL is the standard, and people use it, and it's become ubiquitous. The really interesting thing is, what can't you do with that? And there are a lot of things you can't do that relational technology would allow. And one of the kinds of things is graph style applications, applications that have very complicated relationships that are too difficult to model as a table. And frankly, the algorithms that sit underneath a SQL database can't handle it. So one of the things I've been working on is areas where we can break relational free from the box of SQL. And in two sort of products that I've been working on for the last couple of years, in the operational database side, where people are actually applications that interact one-on-one with humans. People typically use Postgres. Is probably the most common database people are using in that today. But if you think about the data model that people work with, semi-structured is the natural data model for an application that works with people. And the attribute of modern applications is they tend to be very dynamic. And while I would take anything static, an application that was static, I would design in using SQL. If it was a dynamic application that's changing a lot, I think there's limitations there, and that's why document databases have been popular. Well, we've been working on a database called Fauna that brings relational capabilities to semi-structured documents, and essentially introduces the concept of a document data model to work with. It has dynamic capabilities to it, where you can add properties, but you can also do static typing against it. And so I think that bringing the benefits of relational together with other data models is incredibly interesting. And in this case, Fauna, which is this product, has been focused on introducing a new, highly modern database that runs in the cloud. It's fully serverless. It has all the modern characteristics, but also takes advantage of the semi-structured nature of documents. On the analytics side, we've been modeling things. You're the king of modeling, right? Kent, if I want to understand about modeling, I ask Kent. Kent's the person I give a call to. And, you understand this 100 times better than I do. But when I think about the analytics side, I think about the solutions that you can't build today with SQL. And the issues there are primarily algorithmic. So when we talk about Snowflake as the difference that Snowflake drove as architectural, I'm now working on how companies can leverage new relational algorithms to solve different problems. And in the last 10 years, people may not know this, in the last 10 years, there's been an incredible amount of advancement in relational algorithms that allow us to solve recursive problems and many much more complicated joins than the typical binary join mechanisms that are inside today's SQL databases like Snowflake. This is an algorithmic conversation, and I think we're in for a major change in the next 3 to 5 years in how we work with relational data, opening up a lot more capabilities. But to do that, we have to get beyond SQL. SQL will not go away. It will stay important. I think like all sorts of languages like that, it's going to become more of an intermediate language because the large language models will let people interact more in human languages. But while I think SQL will be important, I think we'll start to see new languages introduced that open up relational to new capabilities.
This is what relational AI is.
This is relational AI. This is what relational AI is doing. Mohan Arif, who's the CEO there, has done an amazing job for the last 10 years of leading a team of researchers around the world, literally at major universities around the world. And they've literally written hundreds of new papers. It's all built in papers. It's all done through, same way SQL was done. It's all done through papers that are published papers. So essentially intellectual property that is available to everyone. But it's a long way to go from a paper to a product.
Right.
And they're still working on the product, and it's coming together. I mean, they're pulling it together.
Awesome. So where do you see automation playing a role in all of this? I think it's kind of critical. I could be wrong that we start automating because of the scale that we're dealing with. If we're going to, get any kinds of efficiencies here, with or without AI, is it going to be, AI driven automation?
Well, I mean, it will be AI driven in many cases, but in many cases, it doesn't need to be either, right? A lot of times, it's simply understanding failure scenarios and being able to repeat when problems occur. I mean, when we talk about automation, there's many different dimensions to it. I think automation is critical for everything. I'll just say, to me, it's critical for everything. You want these systems to be self-maintaining and self-running. You say, hey, I want to establish these data pipelines. I want to effect these transformations on the data. This is the way I want the data to look. You want the system to be self-maintaining as much as possible and to deal with whatever issues come up, and also to be able to trigger downstream things within the business. So I do think this is critical, and I think it's going to become very ubiquitous. Fortunately, the tools are, I think, mostly there to do it today.
There's a lot,
AI tools are emerging, of course. Some of those are still new, but we have lots of automation anywheres and and UI paths and all these sorts of things to help us automate aspects of our business, and they're useful. Not to mention tools like DBT and other things.
Yeah. So where do you see things like these concepts around data ops and data products? How does that fit into this evolving landscape that we've got?
Well, I thought, when data mesh was, people were talking about data mesh at first. The big thing to data mesh to me was the way people work together. The discussion about how you build domain-based entities that are thought of as products, and that's just totally right. That's exactly the right way to think about it. Every data team should think about what they're creating as a product that is leveraged either within and potentially outside the organization. And one of the things that's going to change, I think, is more and more over time, and Snowflake has really been a leader here with data sharing, is as you begin to take the data that you've created and treat that as something you share and potentially sell to others, data really becomes a product. I mean, in every way, shape, and form, it's a product. Yeah. But I think people should think about it that way anyway, under all circumstances. And I think that's critical. The other thing I believe, and this comes back to this idea that relational technology, relational is more than SQL, is my thing. It's more than SQL. And over time, I think what we're going to start to see is modeling of business much more. And that's why the other piece to what relational AI is doing is it's really called creating a knowledge graph. And it's a, to be able to take and work with data, not in its more traditional tabular or semi-structured form, but in whatever form makes sense for the business. So being able to structure the data to the business instead of being able to try and structure the business to the data, which is sort of the way we do it today. I've made the statement that I think certainly within 5 years, data ops is going to become more like business ops. And I think and I think that's a great thing, by the way. I mean, to me, that's an incredible career path for people that are in this space, because what it means is that not only will they be thinking about structuring and maintaining a high quality set of data sources for people to do analytics and build data applications on, but they'll also be understanding the attributes of the business and much more directly encoding those attributes into the database itself. That's not possible today. It will be possible in a few more years as we start to see knowledge graph databases appear. And I think people will be building models of their business and deriving everything from those business models. The data model should derive from the business model, not the other way around.
Right.
Today,
and in my history, that's the way I did it originally, right? We was always meeting with the business people, understanding the business and what the business is trying to do, and eventually that might turn into a database, right?
But
based on the needs.
What's really interesting today is what's implicit in that, the data model. The business model is implicit, right? Where is it tell me where that business model is defined that you talked about. The answer typically is on a whiteboard here, in somebody's head, on in a bunch of Slack messages, in a document over there. It's not in any place where it's collectively together, where it can be analyzed like data can be analyzed. That's going to change. It needs to change. It has to change. It has to change.
Yeah. No, it's like back when I started, we did entity relationship modeling, and those were conceptual models. If we were doing it right, we did a conceptual model that was in business terms. So at least we had that part of it. And then you threw in things like data flow diagrams and functional hierarchy diagrams to try to bring that all together. And it has been a challenge, right? And today I hear people talking about like wanting a common semantic model, right? And to me, that's the business model, right? That really is the business model.
Often people are talking about that in the data model context, right? And I think the other thing that's going to drive this, here's what's going to drive this, is I think there's a lot of strong reason to drive it, but I do really feel like the advent of the large language models is going to truly revolutionize this. Because one of the attributes that I realized in the last 2 years as I've been pursuing this holy grail, which kind of is, of a knowledge graph that models the business of an organization and potentially can execute that directly, right? I mean, in a way, that's been the holy grail for many years of modeling. One of the things I've sort of realized that as we've been pursuing this is that understanding the business is so hard. It's difficult to understand, for people to understand the business and then to encode that in something. And I think the large language models are really going to help with that. The realization that my 2023 realization, which is probably a pretty important one, is that the start of a language of a knowledge graph to describe a business is English, because that's where it is. It's going to be in human language. I mean, I say English, but it'd be human language. So whatever country you're in. And so that's where your source of knowledge is. It's the written word someplace. And it's about how can you collect all those tidbits of knowledge, those nuggets of knowledge together and put it into a cohesive business operational plan. How do you do that? And that's where I think these models can help us with that, because they can find stuff and summarize it.
Yeah. Now we get just one question's come in from Mike Ferguson, analyst over in the UK. Do you think we should have digital twin of the business?
Absolutely. Absolutely. And in fact, exactly the right way to put it is a digital twin. One of the areas that I've been focusing on, one of the companies I work on is Julia Hub, which builds the Julia software and the Julia language. And is now really focusing on modeling, engineering modeling, and solving problems in aeronautics and other things. So actually building true digital twins of physical devices, whether they circuits or physical devices. So this concept of digital twins are going to become more and more ubiquitous, I think, and we'll see digital twins of everything. Today, we tend to think of digital twins in the physical world. I've got a digital twin of an airplane wing or something like that I'm modeling. In the future, I think business will absolutely be part of it. It's a very good question, and I think that's exactly right.
Awesome. Well, we're unfortunately running out of time, so I do want to ask you, what's next for you? Are you speaking at any conferences or meetups or anything in the next couple of months
I've
that
got a few
people
more
should look at?
I've got a few more podcasts coming up, so people can look for that. I don't have any, I've got a couple of in-person speaking events up here in Seattle. I'm sort of stuck in Seattle for a couple of months, but I've got a few things coming up with some podcasts and things, so people can look for things there. Mostly, frankly, what I'm going to do right now is put my head down and build product and help my companies build products, because that's what I truly love doing. And frankly, the things that we're trying to create, I'm trying to do things that are new that the industry doesn't have. So there's some risk associated with it. And so it's really worth trying to put some energy into making these things happen, because, if, for example, we can build a knowledge graph that has incredible relational capabilities, it'll solve a set of problems that are not solvable today, and the world will move forward. And so I really think it's worth doing that. And that's where I'm putting my time.
Awesome. Well, unfortunately, with our 30 minutes, I've got still a ton of questions, other things I'd love to discuss with you. So hopefully we can do this again sometime. And it's continuing to evolve, and you have such a great perspective and knowledge of the industry, and not only where it's been, but obviously you're helping direct where it's going. If you're successful with these companies, which I assume you will be, I'm familiar with quite a few of them, and they're on a great road already. So hopefully we can do this again sometime.
It's great, Ted. I'd love to.
Great. Well, thanks for being my guest, Bob. Thanks everybody for joining. Be sure to join us again in 2 weeks, when my guest will be another one of my old industry friends, analyst Sean Rogers will be joining us. Be sure to get out there and like the replays and tell your friends all about the True Data Ops podcast, and check out TrueDataOps.org, where you can sign up for notifications for all our future shows so you don't miss any of these exciting conversations. So until next time, this is Kent Graziano, the Data Warrior, signing off for now.